The small shop owner has bought in the Santa or in any right bazaar.
एक ही जगह पे मिलके those type of plastics are known as thermosetting plastics. Comparison, there are 3 types:
up, down, right, left.
I am not inferior to anyone.
We are TSWREIS. We are top on the Everest. Congratulations.
I want to be a leader.
Hi TSWREIS, today I am going to teach chemistry for first years. Before starting the class, let us recall some basic concepts like atoms, molecules and matter from previous classes. Let me recall with an example. Yes TSWREIS, how this chalk piece made of? Yes, I am asking about this chalk piece. How it is made of? Yes, it is made of a matter. What is a matter? The group of molecules combine together and form a matter. Then what is a molecule? The group of atoms combine together and form a molecule. As we already know what is an atom is. Yes TSWREIS, what is an atom? Yes, atoms are the fundamental particles of matter which consists of 3 subatomic particles. What are they? They are electrons, protons and neutrons. In these 3 subatomic particles, what plays the major role in bond formation? Yes, that is nothing but electrons. Electrons plays the major role in bond formation. Then where does we find these electrons? Yes, in solar system, for example, in solar system, planets revolve in their respective orbits. In similar manner, in atoms, electrons revolve in their respective orbits. The probability of finding an electron around the nucleus in atom is called atomic orbital. Then what about molecular orbital? Yes, the probability of finding an electron around the nuclei in molecule is called molecular orbital. Today we are going to learn about molecular orbital theory. The main goal of this molecular orbital theory is to explain the shape of molecules and to explain the molecule in similar manner how we describe atoms in terms of orbitals, orbital diagrams and electronic configurations. Let us know some more about history of molecular orbital theory. In chemistry, molecular orbital theory is a method for determining molecular structure in which electrons are not assigned to individual bonds between atoms but are treated as moving under the influence of nuclei in the whole molecule. This molecular orbital theory was proposed in the early 20th century and revolutionized the study of bonding electrons by approximating the positions of bonded electrons. And this molecular orbital theory has been developed in the years after valence bond theory had been established, primarily through the efforts of Friedrich Hund, Robert Millikan, J.C. Slater, John Lennard Jones. Okay, let us learn some more about salient features of molecular orbital theory. Salient features of molecular orbital theory. The electrons in molecule are present in various molecular orbitals as the electrons in atom are present in various atomic orbitals. Means what is orbital? Yes, the probability of finding an electron around the nucleus in atom is called atomic orbital. Then the probability of finding an electron around the molecule around the nuclei in molecule is called molecular orbital. So the electrons in molecular orbitals are present in various molecular orbitals as the electrons in atomic orbitals are present in various atomic orbitals. The second salient feature of molecular orbital theory is the atomic orbitals are of comparable energies and proper symmetry combined to form a molecular orbital. Means here we take an example, it is 1s orbital and it is 2s orbital. then these two orbitals are combined to form a molecular orbital? No, these two orbitals does not combine to form a molecular orbital because of their comparable energies are not same. The energy of 2s orbital is appreciably higher than that of 1s orbital. So, these two orbitals does not combine and does not form a molecular orbital. Then and another example is, it is 2pz orbital and it is 1s orbital. These two orbitals are combined to form a molecular orbital? No, because of their different symmetries. So, and it is 1s orbital, it is also 1s orbital. These two orbitals are combined to form a molecular orbital? Yes, these two atomic orbitals are combined to form a molecular orbital because of their comparable energies and proper symmetry. So, the electrons in a molecular orbitals are present in various the atomic orbitals of comparable energies and proper symmetry combine to form a molecular orbital. The third salient feature of molecular orbital is the atomic orbital is influenced by one nucleus, whereas molecular orbital is influenced by two or more nuclei depending upon the number of atomic orbitals combined. Here, as we already know, atomic orbital contain only one nucleus and molecular orbital contains two or more nuclei. It is depend upon the number of atomic orbitals combined. Okay. Thus, atomic orbitals contain only one nucleus and the electrons in atom are present in atomic orbitals and they revolve around the nucleus, whereas molecular orbital contain two or more nuclei and the electrons in molecule are present in various molecular orbitals. They revolve around the two or more nuclei depending upon the number of atomic orbitals combined. Thus, atomic orbital is influenced by one nucleus, whereas molecular orbital is influenced by two or more nuclei depending upon the number of atomic orbitals combined. The fourth salient feature of molecular orbital is the number of molecular orbital formed is equal to the number of atomic orbitals combined. If two molecular orbitals are combined, two molecular orbitals are formed. One is known as bonding molecular orbital and another one is called anti-bonding molecular orbital. Here, the number of molecular orbitals formed is same to the number of atomic orbitals combined. For example, if two atomic orbitals are combined, two molecular orbitals are formed. In that, one is called bonding molecular orbital and another one is called anti-bonding molecular orbital. The fifth salient feature of molecular orbital theory is bonding molecular orbital has lower energy and hence greater stability than the corresponding anti-bonding molecular orbital. Means we already know energy is inversely proportional to stability. So, bonding molecular orbital has lower energy, then it has greater stability. So, bonding molecular orbital has lower energy and greater stability than the corresponding anti-bonding molecular orbital. Okay. The sixth salient feature of molecular orbital theory is the probability distribution of electrons around the nucleus in atom is given by atomic orbitals, as the probability distribution of electrons around the group of nuclei in molecule is given by a molecular orbitals. Means we already know where does we find electrons? Yes, we find electrons in orbitals. In case of atom, we find electrons in atomic orbital. In case of molecule, we find electrons in molecular orbital. So, the probability distribution of electrons around the nucleus in atom is given by atomic orbital, whereas the probability distribution of electrons around the nuclei in molecule is given by molecular orbital. And the seventh salient feature of molecular orbital theory is the probability molecular orbitals like atomic orbitals are combined or filled in accordance with Pauli's exclusion principle, obeying Hund's rule and Aufbau principle. Means the electrons of atomic orbitals are filled in molecular orbitals by obeying these three principles. What are these three principles? Pauli's exclusion principle, Aufbau principle and Hund's rule. Okay. Let us fill in linear combination of atomic orbitals. Yes, okay. According to Schrodinger equation, the electron has both particle nature and wave nature. What is Schrodinger equation? The equation which describes the wave nature of an electron is called Schrodinger equation. So, according to this equation, the electron has both particle nature and wave nature. Where does we find electrons in atom? Yes, as I told you earlier, we find electrons in atomic orbitals. So, according to wave mechanics, these atomic orbitals are expressed by wave functions which represent the amplitude of the electron systems. Okay. However, it is difficult to all electron systems. Thus, linear combination of atomic orbitals method had been adopted. For better understanding of linear combination of atomic orbitals, let us apply this method to homonuclear diatomic molecule hydrogen, which consists of two hydrogen atomic orbitals A and B. A and B. What is the atomic number of hydrogen? Yes, the atomic number of hydrogen is 1. The electronic configuration of hydrogen is 1s1. Each atomic orbital contains 1 electron in the 1s1 orbital in ground state. So, as I told you earlier, according to wave mechanics, the atomic orbitals are expressed by wave functions. What is the symbol of wave functions? Yes, psi is the symbol of wave functions. Psi. According to wave mechanics, atomic orbitals are expressed by wave function. The psi is the symbol of wave functions. So, what happens if two atomic orbitals combine? Yes, if two atomic orbitals combine, molecular orbital is formed. So, psi molecular orbital. As I told you in fifth salient feature of molecular orbital, the number of molecular orbital formed is equal to the number of atomic orbitals combined. Here, see here two atomic orbitals are combined. Then how many molecular orbitals are formed? Yes, two molecular orbitals are formed. One is known as bonding molecular orbital and another one is called anti-bonding molecular orbital. Okay, what is bonding molecular orbital and what is anti-bonding molecular orbital? Okay, let us learn in PPT. Here, bonding molecular orbital results in increased electron density between the two nuclei and is of lower energy than the two separate atomic orbitals. Here, two electrons are combining with same signs in same phase and results in the increased electron density between the two nuclei, and this increased electron density is called bonding molecular orbital, and this bonding molecular orbital has lower energy, then it has greater stability because energy is inversely proportional to stability. The bonding molecular orbital has increased electron density between the two nuclei and is of lower energy than the two atomic orbitals. It has lower energy means it has greater stability. Okay. And what is anti-bonding molecular orbital? Okay, let us see. Anti-bonding molecular orbital results in a node between the two nuclei and is of greater energy than the two separate atomic orbitals. Here, two electrons are combining in different phase with opposite signs and results in the node between the two nuclei. What is node? Node is nothing but where the probability of finding an electron is 0 is called node. When these two electrons are combining in different phases with the different signs, the node it results in the node between the two nuclei, and it has anti-bonding molecular orbital has greater energy, and if it has greater energy means it has lower stability because energy is inversely proportional to stability. Okay. I hope that you understand what is bonding molecular orbital and what is anti-bonding molecular orbital. Due to constructive interference, bonding molecular orbital is formed. Due to destructive interference, anti-bonding molecular orbital is formed. What is constructive interference and what is destructive interference? Okay. Here, two electron waves are combining linearly in same signs in same phases with same signs and results in the constructive interference. These constructive interference results in the formation of bonding molecular orbital. As we already know, bonding molecular orbital has increased electron density, lower energy and greater stability, and these constructive interference results in the formation of bonding molecular orbital. When two electron waves are combining linearly in same phases with same signs, there results in the formation of constructive interference. Due to these constructive interference, bonding molecular orbital is formed. Then what is destructive interference? Here two electron waves are combining in different phases with different size, and these two electron waves are combined, destructive interference is formed. This destructive interference results in the formation of anti-bonding molecular orbital. As we already know, anti-bonding molecular orbital has node between the two nuclei and it has higher energy and lower stability. When these two electrons combine in different phases with opposite signs, there results in the destructive interference. Due to these destructive interference, anti-bonding molecular orbital is formed. As we already know, anti-bonding molecular orbital has a node between the two nuclei and is of greater energy and lower stability. Okay. So, due to constructive interference, bonding molecular orbital is formed. Due to destructive interference, anti-bonding molecular orbitals form. Here asterisk indicates the anti-bonding electrons. Okay, I hope that you understand linear combination of atomic orbitals. Let's we move to types of molecular orbitals. There are three types of molecular orbitals. There are pi molecular orbital, sigma molecular orbital, delta molecular orbital. What is sigma molecular orbital and what is pi molecular orbital? Okay, let's we see. Sigma molecular orbital is a orbital that is symmetrical around the molecular axis. The two electrons in it are called sigma bonds. A sigma molecular orbital may be formed by the direct or head-on-head overlapping. Okay. Here, for example, 2pz orbital is taken as internuclear axis. Here, two 2pz orbitals undergoes head-on-head overlapping and results in the formation of sigma molecular orbital. In this sigma molecular orbital, there are two types, sigma bonding molecular orbital and sigma anti-bonding molecular orbital. As we already know, sigma bonding molecular orbital has increased electron density and it has lower energy and greater stability, whereas sigma anti-bonding molecular orbital has node between the two nuclei and it has greater energy and lower stability. In simple, sigma molecular orbital means it involves head-on-head overlapping. That's all. Means here it is 1s orbital and it is 1s orbital. These two combine through overlapping between the internuclear axis and it is called head-on-head overlapping. These head-on-head overlapping results in the formation of sigma bond. Okay. And what is pi bond? Okay, let's learn. Molecular orbitals of px and py are not symmetrical around the bond axis due to presence of positive lobes above and negative lobes below the molecular plane, and such type of orbitals gives rise to pi bond. In general, here for example 2px orbital is taken as a pi bond molecular orbital. Here two 2px orbitals are undergoes side by side overlapping and results in the formation of pi molecular orbital. These pi molecular orbitals is of two types, pi bonding molecular orbital, pi anti-bonding molecular orbital. Whereas pi bonding molecular orbital has one nodal plane, pi anti-bonding molecular orbital has two nodal plane between the nuclei. In general, pi molecular orbital involves side by side overlapping. This pi molecular orbital is not symmetrical around the bond axis because presence of positive lobes above and presence of negative lobes below the molecular plane. Such type of orbitals are designated as pi bonds. This pi bond is of two types. In pi bonding molecular orbital, it has one nodal plane. In pi anti-bonding molecular orbital, it has two nodal planes. What is nodal plane? A plane where the probability of finding an electron is 0 is called nodal plane. In coming to pi bonding molecular orbital, it has one nodal plane. In coming to pi anti-bonding molecular orbital, it has two nodal planes. Okay. let me see a model. Here two 1s orbitals are combining and results in the sigma bond formation. Here two 1s orbitals are combining and results in the sigma bond formation. These sigma bond is of two types, sigma anti-bonding molecular orbital, sigma bonding molecular orbital. Sigma bonding molecular orbital is of increased electron density between the nuclei and it has greater stability and lower energy, whereas sigma anti-bonding molecular orbital has a node between the two nuclei. It has lower energy, it has lower stability and greater energy. Okay. Here, and it is of example for sigma bonding molecular orbital and it is example for sigma anti-bonding molecular orbital. And another example for sigma molecular orbital is if 2pz orbital is taken as internuclear axis. Here 2pz is taken as internuclear axis. These two atomic orbitals undergoes head-on-head overlapping and results in the formation of sigma molecular orbital. This sigma molecular orbital is of two types, sigma anti-bonding molecular orbital, sigma bonding molecular orbital. Whereas sigma anti-bonding molecular orbital has one node between the two nuclei and sigma bonding molecular orbital has increased electron density between the nuclei and is of lower energy and greater stability. It is of greater energy and lower stability. Okay. Example for pi molecular orbital. Here 2px orbital is taken as example for pi molecular orbital. Here two 2px orbitals are undergoing side by side overlapping and results in the formation of pi molecular orbital. Pi molecular orbital is of two types, pi anti-bonding molecular orbital, pi bonding molecular orbital. Whereas pi bonding molecular orbital has a one nodal plane and pi anti-bonding molecular orbital has a two nodal planes. What is a nodal plane? As I told you earlier, the plane at the way the probability of finding an electron is 0 is called nodal plane. In this way, the sigma bond and pi bond formation or occurs in molecular orbitals. Okay, let's we go to conditions for combining atomic orbitals. What condition should be followed by the combining atomic orbitals? Okay, let's learn. Combining atomic orbital must has proper symmetry and comparable energies. For example, combining atomic orbitals having nearly or near same energy can combine. For example, here 1s orbital and here 2s orbital. These 1s orbital does not combine with these 2s orbital because of their different energies, because 2s orbital has greater energy and 1s orbital has less energy. So, due to this energy difference, these two atomic orbitals does not combine and these 1s orbital only combine with the another 1s orbital because of their comparable energy. So, atomic orbitals combining must having same or nearly same energy. And other condition for combining atomic orbital is atomic orbitals combining have same symmetry. It is important to note that the atomic orbitals combining having same or nearly same energy can combine if they do not have proper symmetry. No, the atomic orbitals having same or same energy does not combine if they do not have proper symmetry. For example, here 2pz orbital. 2pz orbital is combined only with another 2pz orbital, but not with 2px orbital because of their different symmetries. Here 2pz orbital is only combined with another 2pz orbital, but not with 2px orbital because of their different energies. Okay. Let's we go to electronic configuration of molecules. What is the electronic configuration of molecules? The distribution of electrons among the various molecular orbitals is called electronic configuration of molecules. From electronic configuration of molecules, it is possible to get some important characteristics of molecule. Okay. In previous classes, we learned the electronic configuration of molecules, but we also have the electronic configuration of molecules. In previous class, we learned the electronic configuration of atoms. Based on the characteristics of elements, it is of two types: increasing order of energy level for heavier elements and increasing order of energy level for lighter elements. What is the increasing order of energy level for heavier elements? Okay. The increasing order of energy level for heavier elements is sigma 1 is less than sigma asterisk 1 is less than sigma 2s less than sigma asterisk 2s less than sigma 2pz less than pi 2px equals to pi 2p y less than sigma pi asterisk 2p x equals to pi asterisk 2p y less than sigma asterisk 2p z. It is the increasing level of energy order for the heavier elements like oxygen, fluorine, neon. It is not correct for the lighter elements. Then what is the increasing order of energy level for lighter elements? Okay, let us fill in. The increasing order of energy level for lighter elements is sigma 1s less than sigma asterisk 1s less than sigma 2s less than sigma asterisk 2s less than pi 2px equals to pi 2py less than sigma 2pz less than pi asterisk 2px equals to pi asterisk 2py less than sigma asterisk 2pz. It is the increasing order of energy level for lighter elements and it is the increasing order of energy level for heavier elements. It is only correct for heavier elements like oxygen, neon, fluorine. It is only correct for lighter elements like hydrogen, boron, beryllium, carbon, nitrogen, etc. And from the electronic configuration of molecules, it is possible to get some important information about the molecule. We are from the electronic configuration, we are able to know stability nature of molecules and bond order of molecules, bond nature of molecules and magnetic nature of molecules. What is stability nature of molecules? Okay, let me see. Stability of molecules. If Nb is the number of electrons occupying bonding molecular orbital and Na is the number of electrons occupying anti-bonding molecular orbital, and for example, if the molecule is stable, Nb is greater than Na. If the molecule is unstable, Na is greater than Nb, means here Nb is the number of electrons occupying bonding molecular orbital and Na is the number of electrons occupying anti-bonding molecular orbital. The molecule is stable, Nb is greater than Na. The molecule is unstable, Na is greater than Nb. If Nb equals to Na, means number of bonding electrons are equals to number of anti-bonding electrons, it is 0 and the molecule does not exist. Okay? It is the stability nature of molecules. Then what is the bond order of molecules? Okay. Bond order. Bond order is defined as 1/2 of the difference between the number of electrons present in the bonding molecular orbital and the number of electrons present in the anti-bonding molecular orbital. Bond order equals to 1/2 bonding electrons minus anti-bonding electrons. Okay. A positive bond order means Na is greater than Nb is greater than Na. A negative